Okay, let's continue. The useful files in a project. Android Studio project uses the Gradle build system to compile and deploy apps. Gradle project have a standard structure. Here are some of the we'll be working with. Um, okay, step. This is the root folder. This root folder is the name of the project. All the files for a project go here. Okay, this is the root folder. The app folder is a module in your project. Okay, this is a module. The build folder contains files that Android Studio creates for you. You don't usually edit anything in this folder. Okay, how to check? Let me check. I checked. Right. Okay, CPP. This. Then we have build. Now we go to build generated source R debug. There are reports, problems, nothing. Okay, so there is nothing in build. Gradle app source. Let me see. Then the source contains the source code you write in edit. Every Android Studio needs a file called r.java which is created the generated source folder. Well. Android uses this file to keep a track of resources in the app. Okay, there are r.java in my request cpp java res things xml is generated. I cannot open it. Okay, let me open. Hold up. Let me open this application. This one. Right. Okay, so we have this Java generated. Let's show good app package. We go to there is no build app build generated res generated sources out.main. Leave it. Output temp intermediates generated sources. There are no generated sources here. Let me check this. This folder contains any Java code you write. Any activities you create live here. Main activity.java defines an activity. An activity tells Android how the app should interact with the user. Okay. You can find app resources in the res folder. For example, the layouts subfolder contains layouts and the values subfolder contains resources files such as string. You can get other type of resources too. And then activity underscore XML defines a layout. A layout tells Android how your app should look. Every Android app must include a file called Android manifest.xml at its root. The manifest file contains essential information about the app, such as what components it contains, required libraries, and other declaration. The component libraries and declaration. Strings.xml is a string resource file. It includes strings such as apps names and any default text value. Other files such as layout and activities can look up text values from here. Nice. Okay. So we will edit code with Android Studio. You view and edit files using the Android Studio editors. Double click double click on the file you want to work with. and the file's content will appear in the middle. Okay, the code editor. Most files get displayed in the code editor, which is just like a text editor but with extra features such as color coding and code checking. Right. The design editor. If you're editing a layout, you have an extra option. Rather than edit the XML, such as shown on page, okay, you can use a design editor which allows you to drag and drop GUI components onto your layout and arrange them how you want. The code editor and design editor gives different views of the same file, so you can switch back and forth between the. Okay, what's my purpose? Here's a code from an example layout file. What the Visual Studio generated for us. Okay. We know you've not seen layout code before, but just see if you can match each of the description at the bottom of the page to the correct line of code. Okay, include text GUI component. Okay, display. Make the layout the same width and height as the screen device. Screen device. Match parent. There we go. Then make the GUI component just large enough for it. Content. Grab content. Add padding to this. Okay. This is the padding. Okay. Here's a code for an example. We know you. So yeah, this is the make GUI. Yeah, large enough. Display this. Make layout the same size as the parent. Now let's see if we can do the same thing for some activity code. This is example code and not necessarily the code that Android Studio will have generated for you. Match the description below. Okay, this is the package name. This is the package name. These are Android classes used in main activity. Specify which layout to use. Specify which layout to use. I don't see. I don't see. Oh, set content view. Specify which layout to use. This is implement the onCreate method from the activity class. The method is called when the activity is first created. Okay. OnCreate. Implement the onCreate method. This is the onCreate method. So this is the onCreate method. It's this. Yeah, right. Okay. Run the app. Run the app in the Android emulator. So far you've seen what your Android app looks like in Android Studio and got a feel for how it hangs together. But what you really want to do is see it running. You have a couple of options when it comes to running your apps. The first option is to run them on a physical device. But what if you don't have one with you? Or you want to see how your apps looks on a type of device which you don't have. In that case, you can use the Android emulator that's built into the Android SDK. The Android enables you to set up one or more Android virtual devices and then run your app in the emulator as though it's running on a physical device. The Android emulator allows you to run your app on an Android virtual device. You can set up numerous AVDs, each emulating a different type of device. Android virtual device. So what's the emulator look like? Here's an AVD running an Android emulator. It looks just like a phone running on your computer. The emulator recreates the exact hardware environment of an Android device, from its CPU and memory through to the sound chip and the video display. The emulator is built on an existing emulator called QEMU, QEMU, which is similar to other virtual machine applications you may have used like VirtualBox or VMware. Okay. The exact appearance and behavior of the AVD depends on how you set up the AVD in the first place. The AVD here is set up to mimic an Nexus 5X, so it will look and behave like an Nexus 5X on your computer. KMU. Set up an AVD so that you can see your app running on it. Once you set up an AVD, you'll be able to see your app running on it, and Android Studio launches the emulator for you. Okay. Create an Android virtual device. There are a few steps you need to go through in order to set up an AVD within Android Studio. We'll set up a Nexus 5X AVD running API level 25 so that you can see how your app looks and behaves running on this type of device. The steps are pretty much identical no matter what type of virtual device you want to set up. Open the Android Virtual Device Manager. The AVD Manager allows you to set up new AVD and view and edit ones you have already created. Open it by selecting Android on the Tools menu and choosing AVD Manager. If you have no AVDs to set up already, you'll be presented with a screen prompting to create a virtual device. Select Hardware. On the next screen, you'll be prompted to choose a device definition. This is the type of device your AVD will emulate. You can choose a variety of phone, tablet, Wear or TV devices. We're going to see what our app looks like running on an Nexus 5X phone. Choose phone. Choose phone from the category. Nexus 7, click next button. Okay, creating the select a system image. Next, you need to select a system image. The system image gives you an installed version of the Android operating system. You can choose the version of Android you want on your AVD. Okay. You need to choose a system image for an API level that's compatible with the app you're building. As an example, if you want your app to work on minimum 19, choose a system for at least API level 19. We want our AVD to run API level 25, so choose the system AVD with a release name Nougat and a target of Android 7.11. Click on Next and continue. Verify the AVD configuration. The next screen, you'll be asked to verify the AVD configuration, Android virtual device. This screen summarizes the options you choose. Okay, I just need to take a look at fragments, dynamic cycle view, on service information, started services versus async task. Okay, that's okay. 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 And it gives you the option for changing them. Accept the options and finish. The AVD manager will create the AVD for you, and when it's done, display it in the AVD manager list of devices. You may now close the AVD manager. Run the app in the emulator. Now that you've set up your AVD, let's run the app on it. To do so, choose Run App command from Run menu. When you are asked to choose a device, select the Nexus 5X AVD we just created, then click OK. The AVD can take a few minutes to appear, so while we wait, let's take a look at what happens when you run the app. Okay. The run command doesn't just run your app, it also handles all the preliminary tasks that are needed for the app to run. Okay. The Java source file gets compiled to bytecode. Right, bytecode. An Android application package or APK file gets created. The APK file includes the compiled Java files along with any libraries and resources needed by your. Okay. Then we go run. Assuming there's not one already running, the emulator gets launched and then runs AVD. Once the emulator has been launched and AVD is active, the APK file is uploaded to the AVD and installed. Then finally, the AVD starts the main activity associated with your app. With the app, your app gets displayed on the AVD screen, and it's all ready for you to test out. Hmm. You can watch the progress in the console. It can sometimes take quite a while for the emulator to launch with the AVD, often several minutes. If you like, you can watch what's happening by using the Android Studio console. The console gives you a blow-by-blow account of what the build system is doing, and if it encounters any errors, you'll see them in highlighted text. You can find the console at the bottom of the Android Studio screen. Click on the Run option at the bottom if it doesn't appear automatically. Okay, here's the output from the console. This is installed. Damn. Okay, Android Studio has finished launching. Okay, let's install the APK. And we have Android Studio has finished launching. Okay, so shell m start this main activity. The emulator launches our app by starting the main activity for it. This is the activity. This is the activity the wizard created for us. Uh, this is quite. Come down. Then Android Studio has finished launching the AVD we just set up. So let's take a look at what actually happens on screen when you run your app. First, the emulator fires up in a separate window. The emulator takes a while to load the AVD, but then you see what looks like an actual Android device. The emulator launches, and here's the AVD home screen. It looks like wait a bit longer and you'll see the app you just created. The application name appears at the top of the screen and the default sample Hello World is displayed in the middle of the screen. Right? What just happened? Okay. The Android Studio launches the emulator, loads the AVD and installs the app. Right. Installs the app. Then, when the app gets launched, an activity object is created from main.java. The activity specifies that it uses the layout activity underscore xml. Then the activity tells Android to display the layout on the screen. Okay, activity tells Android the node information. You mentioned that when you create an APK file, the Java source code gets compiled into bytecode and added to APK. Presumably, you mean it gets compiled to Java bytecode, right? It does, but that's not the end of the story. Things work a little different on it. The big difference with Android is that your code doesn't actually run inside an ordinary Java virtual machine. It runs on the Android runtime instead, and on older devices, it runs on predecessor art called Dalvik. This means that you write your Java source code and compile into .class files using Java compiler, and then .class files get stitched into one or more files in text format, which is smaller, more efficient bytecode, and Android runtime then runs the text code. You can find okay. Text code. That sounds complicated. Why not just use the normal Java virtual machine? Android Runtime can convert the DEX bytecode into native code that can run directly on the CPU of the Android device. This makes the app run a lot faster and uses a lot less battery. Right, DEX. Is Java Virtual Machine really that much overhead? Yes, because on Android, each app runs inside its own process. If it used JVMs, it would need a lot more memory. Okay. Do I need to create a new APD every time I create a new app? No. Once you've created the APD, you can use it for any of your apps. You may find it useful to create multiple APDs in order to test your app in different situations. As an example, in addition to a phone APD, you might want to create a tablet APD so you can see how your app looks and behaves on larger devices. Okay. Refine the app. Sup dog. Over the past several pages, you've built a basic Android app and seen it running in the emulator. Next, we're going to refine the app. At the moment, the app displays the simple text "Hello World" that the wizard put in as a placeholder. You're going to change the text that says something else instead. So what do we need to change in order to achieve that? To answer that, let's take a step back and look at how the app is currently built. The app has one activity and one layout. When we built the app, we told Android Studio how to configure it, and the wizard did the rest. The wizard created an activity for us and also a default layout. The activity controls what the app does. Android Studio created an activity for us called mainActivity.java. Should respond and how it should interact with the layout controls the appearance. Right. MainActivity.java specifies that it uses the layout Android Studio created for us, activity underscore main.xml. The layout specifies what the app looks like. We want to change the appearance of the app by changing the text that displayed. This means we need to deal with the Android component that controls what the app looks like. So we need to take a closer look at the layout. Okay. What's in the layout? We want to change the sample hello world text that the Android Studio created for us. So let's start with the layout file. If it is already open in an editor, open it by finding app source main rest layout. Okay. The design editor. As we learned earlier, there are two ways of viewing and editing layout files in Android, through design editor and through code editor. When you choose a design editor, you can see that simple text hello world appears in the layout as you might expect. But what's in the underlying XML? The code editor. When you choose the code editor option, the content of main activity underscore main.xml is displayed. Let's take a closer look at that. Activity has two elements. Below is the code from activity underscore mail.xml that Android Studio generated for us. We've left out some of the details you don't need to think about just yet. We'll cover them in more detail through the rest of the book. Here's our code. This okay. So this this is the text view element. This element determines how components should be displayed in the case. Okay, this is really tricky. Okay. Yeah. As you can see, the code contains two elements. This, the first is an Android.support.constraint.constraint layout element. This is the type of layout element that tells Android how to display components on the device screen. There are various types of layout element available. How to display these elements. The most important element for now is the second element, the text view. This element is used to display text to the user, in our case the simple text, hello world. The key part of the code within the text view element is the line starting with Android text. This is a text property describing the text that should be displayed. Okay. And then there's a don't worry if your layout looks. Android Studio may give you slightly different XML depending on which version you're using. You don't need to worry about this because from the next chapter onward, you'll learn how to roll your own layout code and replace a lot of what Android Studio gives you. Update the text displayed in the layout. The key part of the line. Android text means that this is the text property of the text view element. So it specifies what text should be displayed in the layout. In this case, hello world. To update To update the text that displayed in the layout, simply change the value of the text property from hello world to subdog. The new code should look like this. Okay. Change the text. Once you have updated the file, you can save or option. Okay. Let's go. Let's close this. Let's run R. And I wish to don't it zoom. Give view tool window. Uh, how do you zoom? Let me see. How to zoom Android Studio. Zoom editor with Android Studio. Android Studio, go to File Setting, Editor, General, change font size with. We go to File, Settings, General, Appearance and Behavior, Appearance, Zoom, General, yes, okay, better. So we will change this to subdog. Okay. Then why does it give me subdog should be hard to okay, doesn't matter. Okay, so let's put, yeah, let's run it. For you, subdog. Great. If my code layout looks different from yours, is that okay? Yes, that's fine. Android Studio may generate slightly different code if you're using a different version than us. But that doesn't really matter. From now on, you'll be learning how to create your own layout code and it will replace a lot of what Android Studio gives you. I'm right in thinking we're hard coding the text that displayed is purely so that you can see how to update text in the layout. There's a better way of displaying text values rather than hard coding them in the layout, but you'll have to wait for the next chapter to learn what it is. Okay, that's true. Yeah, the folders in my Project Explorer pane looks different from yours. Why is that? Android Studio lets you choose alternate views for how to display the folder hierarchy, and it defaults to Android view. We prefer the project view as it reflects the underlying folder structure. You can change your Explorer to project view by clicking on the arrow at the top of the Explorer pane and selecting project. Take the app for a test drive. Once you've edited the file, try running your app in the emulator again by choosing Run App command from the Run menu. You should see your app now says Subdog instead of Hello World. You've now built and updated your first Android app. Version of the Android, API name, layout, text field. Building interactive apps that do something. The window, what happens? Just most app needs to respond to user in some way. In this chapter, you'll see how you can make your apps a bit more interactive. You'll, s- you'll learn how to get your app to do something in response to the user and how to get your activity and layout talking to each other, like best buddies. Along the way, we'll take you a bit deeper into how Android actually works by introducing you to R, the hidden gem that glues everything together. Let's build a peer advisor app. In chapter 1, you saw how to create an app using the Android Studio New Project Wizard and how to change the text displayed in the layout. But now, but now you create an Android app. You're going uh, usually going to want the app to do something. In this chapter, we're going to show you how to create an app that user can interact with, a peer advisor app. In the app, user can select the types of beer they enjoy, click a button, and get back a list of tasty beers to try out. Here's how the app will be structured. Layout specifies Layout specifies what the app will look like. It includes three GUI components, a drop-down list of values called a spinner, which allows the user to choose which type of beer they want, a button, a button that when pressed will return a selection of types, a text field that displays the type of beers. Okay, so we have the layout. Then the file strings.xml includes any string resources needed by the layout. For example, the label of the button specified in the layout and the types of. Okay, we have then strings. The activity specifies how the app should interact with the user. It takes the type of where the user chooses and uses this to display a list of where that might the user might be interested in. It achieves this with the help of a custom Java class. Okay, the custom activity. The custom Java class contains the application logic for the app. It includes a method that takes a type of where as a parameter and returns a list of where of this type. The activity calls the method, passes it the type of where and uses the response. Okay, so बाहर से कुंडी लगा देना हाँ हाँ So here's what we're going to do. So let's get to work. There are a few steps you need to go through to build the Beer Advisor app. We'll tackle these throughout the rest of the chapter. Read the project. You're creating a brand new app, so you'll need to create a new project. Just like before, you'll need to create an empty activity with a layout. Okay. Update the layout. First, we create the project. update the layout. Once you have the app set up, you need to amend the layout so that it includes all the GUI components your app needs. Okay. Then connect the activity layout to the activity. The layout only creates the visuals. To add Smarts to your app, you need to connect the layout to the Java code in your activity. Write the application logic. Right, you'll add a Java custom class to the app and use it to make sure users get the right pair based on their selection. Okay, to create the project, let's begin. Let's begin by creating the new app. The steps are similar. Open Android Studio. When prompted, enter the application name, create Visa. Okay, so let's create. This is done. Let me create a new project. MTV's activity. We will store it not here, but rather project development. Getting started. Okay. Wait. Don't getting started. First app. Let me add a folder. Dash peer advisor. Okay. In here. Name of the application. Peer advisor and Java. Finish. Close this one. Don't need that. Include folders. Yes. Okay, when prompted, enter the application. Make sure you uncheck. We want the app to work on most phones and tablets. API 19. Choose an empty activity by default for the activity. Okay, make sure the option to generate the layout is selected. You check. This. This. Okay, we've created a default activity and a layout. Right. Hmm. Um, okay, I didn't get the option to change the activity name. Can I change the activity name? I don't think so. So, wait, let me create this again. I should Android Studio. Yeah, there's not literally not. So, hold up. Now it should. Yeah, where does my application project interviews activities? I don't get to choose my activity name, package name, create a new activity. Empty activity, is that it? Previous basic, no activity. Finish. There is no next button. Previous, um, basic view activity, save location package name. Uh, um, how how to change how to change the activity name studio. Do that. Advisor. Okay. Just continue that. Very good. Okay. We've created a default. Okay. When you click on finish activity, it has doesn't matter. When you click on finish button, Android Studio creates a new project containing an activity, find p activity.java layout. Let's start by changing the layout file. To do this, switch where we need this activity, right? Delete it. Studio fields that are not safe to delete. Use it. Okay. Main activity and what other sources? That's okay. I can create. This is okay. I can update the manifest. Right. Label and activity, right? Main activity. I'll update it. Doesn't matter. So let's delete this. Delete anyway. Okay. Where's sorry layout. Delete. Okay. Now I will add new activity. Empty view activity. The activity name is what is the name of the activity? Find peer activity dot java. Peer activity in source language Java. Java and activity find peer.xml. Start by changing the layout file. Finish. With this and I will say if this is not valid, cancel. Dot main activity. So dot find activity. You good now? Okay. That dot that dot is not required. Okay. Okay, so we will change back here. Let's start by changing the layout file. To do so, switch to project view of Android Studio Explorer. Go to App Source Main Dress Layout. Then switch to the text version of the code. to open the code editor and replace the code with the following. We have bolded all the new code. So we will write linear layout. We're replacing, we're replacing the code Android Studio generated for us. These elements relate to the layout as a whole. They determine the layout, width, height, and any padding in the layout margins, and whether components should be laid out vertically or horizontally. And this is used to display text. We've just changed the code. It uses a linear layout. This is used to display GUI components next to each other, either vertically or horizontally. If it's vertically, they're displayed in a single column. If it's horizontally, single column displayed in a single row. Okay, any changes you make to a layout. Okay, so let me add this here. Nope, we're not using simple linear layout. Then we define, okay, we define Android width and layout height. We define layout width and layout height. Match parent layout width. I should close it with, yeah. Okay, so we open it like that and we close it like that. Okay, no, we don't close it like that. Alright, so this is within, this remains within this. Let me just, yeah, linear. Then we define, then we define everything, define, we define everything between these, right? So X, M, L, N, S, then it goes Android equals to HTTP schemas dot android dot com apk res android. This is the, I don't know, I don't understand. Okay. Insert layout, layout width should be defined. Element doesn't have required attribute. Okay, we will add them. We should for the time being just right. Okay, these are the properties from XMLN tools. XMLS tool equals to HTTP schemas dot android.com tools. Then we go Android layout underscore width, layout underscore width equals match parent and Android layout underscore height equals match parent. Then we provide a padding. cannot add comments or comments the same way. Um, so add wait. Although that just close it like that, right? But it still gives an error. Okay, now it's here. Gives some error. Index actions. Um, does it give an error? Wait. I think I know how to add comments. I learned that, dude. Links, markup. I think we can add comments. Should show some comments. Uh, maybe I'll have some comments here. Three comments. Yep. Dash dash and dash dash dash. That's what I wrote. That's what I dash dash. Okay. Okay, no errors here. And gives an error. Okay, maybe I cannot add comments there. Okay, match. Vertical. Okay, then we add padding. Android padding equals 16 dp. 16 dp. Then Android orientation is vertical. Then tools context. Tools context equals dot. Okay, so we define form dot sample dot peer advisor dot find peer activity. Okay, then we add a text view in here. Text view. Then we provide an ID, Android ID. Why does it give an error? Okay, insert here. Okay, that's okay. I'll do it. Android ID at the rate plus ID slash text view. At the rate plus ID text view. Then we provide Android layout width with equals match parent content Android layout hide wrap content. Okay, just that. I could just have it this and then but it gives me an error. XML has an empty body. Okay. This looks cool. And that is any changes you make to the layouts XML are reflected in the Android Studio's design editor, which you can see by clicking on the design tab. Closer look at the design editor. The design editor is text view. That is new text. Android text. This is a text view. So, text equals this is a text view. It shows us the text view. A closer look at the design editor. Maybe I'll cover it later.